Hello everyone, today we're going to take a look at paper 1. So basically it says the Cambridge IGCSE exam, read the instructions clearly, and then make sure that you understand this part as well. It says take the weight of 1 kilogram to be 10 newtons. So you can kind of round up the 9.8 meters per second square to 10 meters per second square. Alright, now a long runner distance wishes to calculate her average speed for a race. Which calculation should she use? So you're trying to calculate the average speed. Now, if you remember from this triangle that we drew, we know that distance is speed multiplied by time. So if you're trying to figure out the speed, you could say the average speed is equal to the distance over time, right? Which would rule out choice C, choice D, and choice B, leaving us only choice A as the correct answer. Total distance over the total time. A heavy metal ball falls vertically downwards through the air past 4 equally spaced levels, J, K, L, and M. The time taken to fall from one level to the next are measured. Which is the speed of the ball? Where is the speed of the ball the greatest, and which time is the shortest? Now, when objects are freely falling downwards, we know that as they go down, their speed increases, right? So the speed of the ball at level J would be high, but it would be higher at K. It would be even higher at L, and it would be the highest at level M. Which would mean that if it's passing between L and M, it would take the shortest amount of time and it has the highest speed. That would rule out choice A, B, and C says it's the greatest between L and M, which is correct, but it says the time is shortest between J and K, which is wrong. So that only leaves us with choice number D. Now, question 4 says an arrow travels horizontally in a straight line at constant speed. In which direction does the weight act? Now, if you guys remember anything about weight, you do know that weight is a downward force that is caused by gravity. Now, notice that I said downwards. That will leave only choice A as the correct answer. 2 rectangular blocks consist of different materials. 4 different methods are suggested to compare the two masses. Compare the accelerations with which they fall freely. Not really. Compare the values of their lengths. That would give us the volume. That wouldn't work. Hang each and turn from the same spring. Compare the extensions. That would work because we're trying to compare the two masses, and a bigger mass would create a greater extension. Place one in the right-hand pan of a beam balance and the other in the left-hand pan. That would also work. So 3 and 4 are so far correct. Which methods give a comparison of the two masses? A would be wrong, B would be wrong. The answer is C. Now let's take a look at question number 7. It says a mass of 20 kilograms is held stationary by a rope passing over a frictionless pulley. What is the tension T in the rope? Okay, first of all, it's stationary, which means that the pulley is not moving, right? The mass is not moving. And so in order to find out the tension in the spring, you need to find out what the weight of this mass is, which would be 20 kilograms times, you know that weight is equal to mass times gravity. Now, since at the beginning it says gravity, or G is 10, we can say 10 meters per second square, which would leave us with, over here, obviously, we would have to convert that into newtons per kilogram. Where kilogram and kilogram cancel out, leaving us with 200 newtons, which means that choice D is the correct answer, and the tension in the rope is also 200 newtons. Question number 8 says, a spring is suspended from a stand, loads are added, and the extensions are measured. Which graph shows the result of the plotting extension against the load? Now, this has to do with the Hooke's law. Basically, when you put more load on a spring, it starts to stretch. But at the beginning, the spring is obviously it doesn't have any extension, so its extension is equal to 0. That would rule out choice C. The extension is not going to decrease as you put more load, so A is also wrong, right? And this horizontal line is not correct, so B is also wrong. That would only leave us with choice D, which is correctly showing that if you put more load or if you put more weights around on the spring, then the extension is going to increase. Question number 9 says, they're trying to rotate this wooden bar, and they're asking you to find out the greatest turning effect, which is obviously the moment. Now, we know that if you increase the distance of force from the pivot, the moment is going to increase. And you also have to, find out whether the wooden bar is even going to rotate at all. I mean, in D, the forces are in the same direction, so the rotation might not even happen. And C, it's right at the center, so similarly the same idea. And for B, the forces are not that far apart from the pivot. I mean, especially the second one right there. So B is obviously ruled out as well, leaving us with choice number A. Number 10 says a machine is very efficient. What does this mean? Well, the efficiency of a machine can be easily calculated by, taking a look at the useful output, basically the useful output over the total input, right? When you divide these two variables, your total input over the useful output, you find out the amount of efficiency a machine has. Now, it doesn't have to do anything with power, so A is gone. We don't know how much energy is used, so B is also gone. And working quickly is also wrong, which would mean choice C is correct. It wastes little energy, right? When something is very efficient, it wastes a little amount of energy, which means that it produces a higher amount of useful output given the amount of input that you gave to the machine, which would make choice C correct. An object is lifted vertically by a motor, question 11. In which example is the power produced the greatest? Now, the power of a machine or a motor right here, we're considering the mechanical power, is going to be the energy over the time. Now, if something has a high amount of power, it produces a lot of energy in a short amount of time, right? So it should do the same distance, not the shorter distance, but in a shorter amount of time, which would make choice D the correct answer. Let's go down. It says 4 identical submarines P, Q, R, and S are lowered from one depth to another in water of a constant density. The initial and final depths of each submarine are shown in the diagram. Which row is correct for the difference in pressure from the initial to the final depth of each submarine? Okay. So, we do know that if we go from, if a submarine P goes from 10 meters to 30 meters, its pressure is obviously going to increase. And the same goes for a submarine Q, which would, it's obviously decreasing, is going down by 20 meters, 50 to 70. Same goes with P. But for R and S, R is going from a depth of 10 meters to 15 meters. That's an increase of 40 meters. And the same thing goes for S. Now, the deeper you are in the water, you know that pressure increases with depth. So that would mean that the greatest amount of increase in pressure would be for R and S. But the least amount of change in pressure would be for P and Q because, well, they're obviously increasing or their depths by 20 meters each, which would make choice number A the correct answer. The greatest change in pressure would be for R and S. The least change would be for P and Q. The diagram shows a stone suspended on a string on the surface, under the surface of a liquid. The stone experiences a pressure caused by the liquid, which would increase the pressure on the stone. The pressure on the stone can be increased by, can it be increased by decreasing the surface area? Not really. Increasing the mass of the stone? Not really. Doesn't have to do anything with pressure because we know that pressure obviously can increase by depth in a liquid. And then lowering the stone deeper into the liquid, that would work. So that is correct for now. And using a liquid with lower density, no. The answer would be C. Lowering the stone deeper into the liquid because we know that pressure increases with depth. Why can a gas be compressed easily into a smaller volume? Well, the reason is, in a gas, we know the molecules are far apart, so that's obviously one of the main reasons. They do not attract each other. That has nothing to do with this. They move randomly. They do, but again, nothing to do, and the volumes cannot be, no, that's not correct. The answer is A. When a liquid evaporates, some molecules escape, the temperature of the remaining liquid changes. What is the effect on the temperature, and from where do the molecules escape? So, when the molecules escape from a liquid, their kinetic energy decreases, and so in turn, the internal energy of that substance decreases. When the internal energy of a substance decreases, so does its temperature. And so if the temperature is decreasing, that would rule out choice C and D. Now, since it's evaporating, evaporation only happens at the surface. So that would make choice B the correct answer. What happens when a metal block is heated? Its breadth, height, and length all increase. Its width increases, its height increases, and its length increases. That would be wrong, and you can think about it like this. The correct answer is A. When a block of the iron is melted, it's going to increase all of its dimensions, its height, breadth, and length. And so as a result, choice A would be correct. It says, a night storage heater contains a large block of material that is heated electrically during the night. During the day, the block cools down, releasing thermal energy into the room. Which thermal capacity and which nighttime temperature increase will cause the most energy to be stored by the block? Now, you can think of this as if something has a large thermal capacity, it's going to be able to store large amounts of thermal capacity. But for that thermal capacity to be fully, I guess you can say, satisfied, you need to also give it large amounts of heat. So that would rule out choice C and D because it says small thermal capacity, leaving us with choice A and B. But if you have a large thermal capacity, why would you want to give it a small amount of temperature increase, right? So B is also gone, and the answer is A. Question 18 says, the diagram shows the change of state P, Q, R, and S that occur in solids, liquids, and gases when they gain or lose thermal energy. So we know that when you go from solid to liquid, before I even answer the question, solid to liquid is obviously melting. And then liquid to gas would be evaporation. I'm just going to write evap. And then liquid to solid would be freezing. And gas to liquid would obviously be condensation. So that would rule out choice D, C, and B, which would leave us with, it says change R, which is right there, condensation. Choice A. It says, in which does thermal conduction not occur? In a gas, a liquid, or solid, or a vacuum? Now, thermal conduction was when heat was transferred with the vibration of molecules. So for thermal conduction to happen, there needs to be a presence of molecules. You have no molecules in a vacuum, and so the correct answer is D. I wouldn't even look at the other answers, just to save more time. So it says, the metal surface of a kettle is hot. What happens to the cool air outside the kettle when it comes into contact with the hot kettle? Now, whenever cool air is heated, the molecules go further apart. So the same volume, let's say you have two of the air. This is the cold air, and then this is the hot air. The same volume of the hot air always have less density because the molecules are further apart, and as a result, they rise into the air, which would mean, so obviously the density of the air would decrease, which would rule out choice C and D, leaving us with A and B. But does the air rise or fall? If the density decreases, the air obviously rises, which would leave choice B as the correct answer. Ultrasound is used in hospitals to scan a patient. The ultrasound refracts at a boundary between the muscle and the bone because it travels at a greater speed in the bone. Which change takes place when the ultrasound travels from muscle into bone? Okay, so in order to understand this, you're going from muscle to the bone. Your speed is increasing. Now, the wavelength or the lambda of an electromagnetic wave is essentially the speed divided by the frequency, right? So if your speed is increasing, then you know that lambda is equal to the speed over the the speed is increasing. So anyways, the speed is increasing, and so they have a direct relation to each other. So if the speed is increasing, then the wavelength is also going to be increasing, which would mean choice D is the correct answer. Thank you for watching, and stay tuned.